Okay, so this is the requirement for each bag and each hour. Okay, and the total available time for each department. Okay, this is a total available time for each department. Okay, all right. So this is a estimation lah. Okay, so the estimation in next 3 months. Remember the duration is for next 3 months. Okay, so next one the availability. Hours for cutting and dyeing is 630 hours. Sewing is 600 hours. Finishing 708 hours. Fashion and packaging 135 hours. Okay, so based from this is a total number hours. They calculate based on working hours, daily working hours, and total number of employees that available. Okay, so but the details we don't know, but they already calculate the number of hours. Okay, I'm so sorry if my background disturbing. My I think my neighbors is in the progress to renovate their house. Okay, all right. Okay, so this is the resources that they need to produce these two bag. Okay, this type of bag, medium, standard bag, and the large bag. Okay, so next is the profit contribution for each bag. Is standard bag is $10 per unit and the large bag is $9 per unit. Okay, profit contribution. When you want to maximize, we will maximize the revenues. We will maximize the sales. Okay, normally business would like to maximize the profit. Okay, because profit is actually what the business get. Revenue, if even though you have 1 million revenue, 1 million sales, but still, let's say if you have 1 million sales, but your cost is 900,000, then you only get a profit about 100,000. Okay, so the measurement that it's not relative. Okay, so the figures for revenue doesn't give any meaning. Okay, even though you say, oh, this company have a revenue 2 million. Okay, so it doesn't give any meaning. Is it they get so many? Yes, they sell at a highest quantity, but what is actually the companies get? Actually, companies get is profit. Okay, based on profit. Okay, that's why to measure for business performance is not based on the revenue. It's based on the profit or cost. Okay, cost operating cost. Right. Okay, so profit $10 per unit and the last bet $9 per unit. Okay, so this is the availability of their resources. Okay. All right, so now the next step is we will develop a mathematical model, okay, to determine the number of standard bags and the number of deluxe bag to produce to maximize the total profit contribution. Okay, so this is what they have now, the resources. Okay, so they have 4 department and the availability of the each department and employees for each department. Okay, total. Okay, and then they have a profit contribution. So based from this, we can determine how many deluxe bags to produce and how many standard bags to produce, so that they can maximize the total profit contribution. Okay, they can just randomly, as long as you can fulfill all the requirement, but it's okay. But is it that you get the maximum profit or not? Okay, all right, so that's why we use a linear programming to determine the actual figures that will determine and will maximize your total profit. Okay. All right, so now first we will do some problem formulation. Okay, so what is a problem formulation? In the problem formulation, okay, so this is a first step. Okay, so when you get a problem, so you have to formulate the problem. Okay, formulate a problem or problem modeling. Okay, so in this step is that you will translate the verbal statement into mathematical statement. Okay, so this is a verbal statement. Okay, I explain to in verbal. So company have a cutting and dyeing to produce one standard bag is about 7/10 hours. Okay, deluxe bag 1 hour, and the maximum hours is cutting and dyeing. Okay, 630 hours. Okay. All right, so now we will like to translate that into a mathematical statement. Okay, so this is a guideline. Okay, to before we do a problem formulation, I will explain a guidelines. Okay, or step to do a problem formulation. All right, so first, whatever before you formulate the problem, first you have to understand the problem thoroughly. Okay, all right. So in the power corporation problem, they would like to produce 2 bag, medium bag, and standard bag and deluxe bag. Okay, with profit contribution for each standard bag is $10 and deluxe bag is $9. Each bag has to produce to go through 4 department. Okay, so and the requirement has mentioned, and they have a maximum availability for each department. Okay, so you have to understand when you get the problem, you have to understand the problem before you can solve it. Okay, all right, then identify, describe the objective. Okay, describe the objective. You have to determine the objective of that problem. And after you determine the objective, you have to describe each constraint. What is the constraint for the problem? Okay. Then what is the variables? Okay, the variables for each decision in the problems. Okay. And then you have to translate from that, you translate write the objective in terms of decision variable. After you get the decision variable, we will use objective and constraint in terms of decision variables, and also constraint lah. Okay, objective and constraint. Okay, all right. So we go to next. Okay, so this is for the power incorporation problem. Okay, so the objective, okay, so objective, let me see. Okay, so objective for this problem is to go back. Okay, so objective here to maximize the total profit. Okay, maximize total profit by determine the number of standard bags and deluxe bags to produce. Okay, so this is your objective. Okay, number of standard bags and number of deluxe bags to produce, so that you can maximize the total profit. Okay, so this is your objective. Okay, so constraint, based from this constraint is the resources that that the company have. Okay, so in this case, okay, so the company have 4 constraints. Okay, so 4 constraints here because it have 4 departments. Okay, so each department have the maximum availability number of hours. Okay, have availability. Cutting and dyeing only you have 630 hours. Whatever quantity that they plan, they should fulfill the requirement that up to 630 hours only. Okay, so the company for this cutting and dyeing must be less than 630 hours or equal lah, must be less than or equals. Because it's availability. Okay, so it's available. So when it's available, you cannot use more than that amount. Okay. If they said, oh, so the company, the cutting and dyeing time, minimum hours should use is 630 hours, means that they should use more than 630. But in this case, the available is only 630 hours, so you cannot use more than 630 hours. So when you want to plan to produce that, up to 630 hours only for cutting and dyeing. And sewing time, okay, sewing, the availability is 630 hours, okay, and finishing is 708 hours, and also inspection and packaging is 135 hours. Okay, so in this case, the constraint only based on the resources that they have. Okay, okay, you already identify the objective and then your constraint. Okay, all right, and then we will assign the variables. Okay, remember the step here. Okay, understand the problem before, and then objective, you know the objective to determine number of medium bags, standard bag and deluxe bags to produce. Okay, so that you can maximize the total profit. Constraint, you have 4 constraints. Okay, number of hours, availability hours for cutting and dyeing, availability hours for sewing, finishing time, available hours for finishing time, and then availability hours for inspection and packaging. Okay, so far okay? Hello, okay ke? Are you okay?
Okay, doctor.
If I'm going too fast, please slow me down, okay? All right. Because sometimes I don't realize that I'm going too fast, okay? All right. Next is to assign the variable, to define the decision variables. Assign variables for each decision. Remember, your objective is to determine number. Okay, so this is your decision, number of standard bags and number of deluxe bags. So now we will assign the variables. So in this case, let's say I assign S for number to represent number of standard bags, because we see that it doesn't have any number, so we use S to represent that. Okay, all right, and then D number of deluxe bags. Okay. All right, so we don't know yet what is number of standard bag and number of deluxe bags. Okay, so now we already have variables. Then we will write the objective in terms of decision variables. Okay, all right. So if PA makes $10 for every standard and $9 for every deluxe bag, so okay, profit for standard bag kan. Okay, to calculate the profit for standard bags, $10 and $10 times by number of standard bags to produce. Okay, right. So number of standard bags ni we represent by S. Kan, number of. So 10 times S. So now profit standard bag is 10S. Profit for deluxe bag. Okay, profit for deluxe bag $9 times by number of deluxe bag. If deluxe bag you produce 10, so means that profit for deluxe bag is 90. But now we still don't know yet what is the figure for deluxe bag. Okay, so that's why we use D to represent number of deluxe bag. Okay, so 9 times D or 9D. Okay, so to represent the total profit for standard bags and profit for deluxe bag. Okay, so total profit for both is 10S plus 9D. Combine both. Okay, this is the total profit for both standard bags and deluxe bag. This is what we call an objective function. To maximize total profit, 10S plus 9D. Okay, you have to inform this maximize. Okay, maximize to show to your readers or your audience that this programming, this function, this linear optimization is to maximize profit. Okay, all right. Okay. Okay, so next, okay, the next step is to write the constraint in terms of decision variables. Okay, write the constraint in terms of decision variables. Okay, so you have a 4 constraint, remember? So constraint 1, number of hours and cutting, number of hours of cutting and dyeing time used. Okay, all right, so hours of cutting and dyeing time used. Okay, from here, see. Okay, is 10 times S plus 1 times D. Okay, so this is the hours cutting and dye use, but remember you have the maximum number of hours. Okay, so hours of cutting and dyeing time available from this table is 630. Okay, the available is 630. So means that the sign is less than or equal to. Okay, so whatever, when you calculate here, when whatever hours you use must be less than hours available. Okay, use less than available. You cannot use more than what available, but you can use equals to available. If you have $100, you can spend up to $100 or less than that. Okay, you cannot spend more than $100. Okay, the second constraint, hours of sewing time used. Okay, so this is from this table. So this is hours of sewing time used for both bag, and hours of sewing time available. Okay, from this table here. Okay, 600. Okay, available means that same as previous, less than or equal to. Okay, so constraint number 4, number of hours of finishing time used. Is this combination for standard bag and deluxe bag from this table, and hours available from this table is 708. Also, because it's available is less than or equals to. Constraint number 4, last constraint, inspection and packaging time used. Okay, number of inspection and packaging time used. This is a combination for both. And available here 135, also less than or equals to. Okay, so less than. Okay, so from this one, each constraint, now you can combine. Oh, so sorry, last one is that non-negativity constraint. Okay, so you have to mention that non-negativity constraint means that your product cannot produce in negative value. Okay, you have to avoid that negative negative 10 standard bags to produce. Okay, because you cannot produce in a negative value. Okay, all right, so you have to mention that non-negativity S and D is more than or equals to 0. Okay, so in Excel later there's some area that you should tick that. Okay, all right, so this is a 9. But in a writing mathematical statement, when you write a mathematical statement, you should state that this non-negativity constraint. Okay. Okay, so this is the full mathematical model or mathematical statement for par incorporation problem. Okay, so this is the objective function. First, you must have an objective function here. Okay, maximize 10s plus 9d. And then first constraint, second constraint, third, and the last constraint, and non-negativity constraint. Okay, negativity. Non-negativity constraint. Okay, so this is how you should write. It's subject to maximize profit is subject to, so this is the constraint. Okay, subject to constraint. Maximize the profit or maximize, in this case is a maximize profit lah. Maximize the profit subject to all these constraint. Okay, and then this is a non-negativity constraint. Okay, mathematical statement, right? Okay, so revision as to just to remind you, first to describe object, sorry, typo here, objective. Describe a constraint. Okay, I mean that more describe to is you have to understand lah objective, and then you have to understand constraint, and then you have to define the decision variables, how many decision that do you have, and then assign the variables, and then write objective function in terms of mathematical statement, and write the constraint in terms of the mathematical statement. Okay, so now that's only to write the mathematical statement. It's quite difficult to, still you don't have any decision, okay? All right, so now we would like to solve, we would like to solve this par incorporation problem using Excel, okay? Excel. If you have Excel, if you want to open the Excel, Okay, per Excel file, per. Okay, sorry. Okay, so this is a file from previous semester. Okay, all right. So this is a PAR file, Excel file. If you want to open, then you can open the Excel file here. Okay, so this area, I put a color blue color. This is the input area. Okay, so this is the input from the table. Okay, so from the table, input area. Okay, so available number of hours to produce each bag. Okay, each model and each bag, each hours. Okay, so this is the maximum availability hours. Okay, and this is a profit per bag. Okay. All right, so this is a copy from copy the mathematical statement from the what is it, PowerPoint. Okay, from PowerPoint I paste here. Okay, as a reference. Okay. All right, so now we want to run the solver. Okay, so in linear programming, we use the solver function. Okay, solver to identify, to determine number of standard bags here to produce and deluxe bags to produce. Okay, okay, so this is, let me explain the area. So this is input area. So normally we will put all the inputs in this area. This is your decision, okay, how many standard bags to produce and how many deluxe bags to produce. Okay, this is your objective to maximize the total profit. I put the color in red color. Okay, this is me put a coloring. Okay, all right, standard bag, deluxe, number of standard bag, number of deluxe bag, maximize your objective, and this is your constraint. Actually use and the availability. Okay. All right. So this is provided to you. This figures is normally we provide data. We provide to you. Okay, for you. Okay. So now go to the data ribbon. Okay. So data ribbon. You can see that in the analyze here or analysis here, you have a solver. If you don't have a solver, don't worry. Okay, don't worry. Let me remove. Okay, let me remove in my Excel. Okay. All right. So by default, normally there's no solver function here. Okay. You already insert the data analysis here. Analysis icon here. Then we will add a solver. Okay. Go to the file ribbon. Click the file and go to the bottom of this area. Bottom here, because my laptop is quite small. Screen is quite small. Then I have to click more. And click option. Okay, option. Go to the bottom. If you have no more, then I think probably some computer it can display up to option. Okay, so because my laptop is quite small, then I have to click more and click option. Okay, so in option on the left side here, you have general formulas and go to add-ins. Okay, so add-ins, you click add-ins, you can see the windows here. Go to the bottom one, manage. Okay, so make sure click Excel add-ins. Okay, Excel add-ins, and then go add the solver add-ins. Okay, solver add-in. You can see my Excel, isn't it? You can see the windows pop up here. Can you see it?
Can, Dr. Can.
All right, thank you. Okay, click solver add-in and then click OK. There's solver here. Okay, we will use solver to solve this problem. Okay, all right. So mathematical statement is only to write the statement to help your audience or your reader to understand about your problem. Okay, all right. So click solver. Reset all. Okay, reset all first. Okay, so this is should be blank here. Normally when you get a data file, blank here. Okay, we have a set objective to maximize or minimize by changing the variables as subject to constraint. Okay, subject to constraint. Okay, so first set your objective. Your objective is here, red color, objective. Okay, to maximize the total profit. Okay. To maximize, then make sure you tick maximize, okay, not minimize. Make sure tick maximize in this case, okay. Set objective, click a total profit area here. By changing, sorry. Cancel. So sorry, I missed one step. We should set the formula first before we go to the solver, okay. Sorry. All right, so we should set the formula here, okay. So formula here, this maximize 10SD, 10S plus 9D. Okay, so we should set the formula here. Okay, so we want to set the formula equals to, okay, so this in the linear, if your mathematical statement is in a linear form, okay, so you should equals to, we will set as sum product, okay, sum product if in linear form. Okay, so sum product time rather 10S plus 9D. So S, this is for S. Yes. This is actually S. This one is S and this is D. Okay. Number of standard bags to produce and number of deluxe bags to produce. Okay. So this is S, this is D. This is 10 and 9. Okay. All right. The first set. Okay, if your mathematical statement is in a linear form, equals to put in sum product. Okay, double click sum product. 10S 9D, select 10 and 9, and then comma. Okay, so depends after your array 1, is it a comma or semicolon? Depends to your Excel, type of Excel. If your Excel put it semicolon, you have to type semicolon. Okay. All right. The second array is SD here. Okay. So select SD. Select 9, 10, and 9, and then select SD. And then enter. Okay. All right. So enter. There's still 0 because there's no number of figures in standard and deluxe bag. Let's say I put here 10 and 10. Okay. So the maximum total, total profit is 190. But we're not sure whether this new combination, is it the maximum profit or not? Okay. All right. We're not sure. This is before we run the solver. Okay, and then next is use to set the formula in use and available. Okay, so use for each constraint and availability for each constraint. Same as profit, because this is a linear form. So we use sum product. Use sum product. Okay. Sum product, cutting and dyeing here. And then comma, standard and deluxe. Okay, enter. Okay, so this is how you set your formula, because you set 10, 10. So by producing 10 standard and 10 deluxe, you only use up to 70 hours only. Okay, next is for sewing, equals to sum product. Okay, so sum product, and then select for sewing. Array 1 and then array 2 will times by S and D. So sorry, this is SD, and enter. Okay, enter. Next is for finishing, sum product. Okay, finishing and comma and standard and deluxe. Enter. equals to inspection some product, okay, some product here, and comma and standard deluxe. Okay, so follow this one. Okay, enter. Alright, so this is all these hours used ni is based on 10 and 10 standard bag and 10 deluxe bag. Let's say if you change it to 100 and everything will change here. Okay. Okay, so number of available. Okay, so number of available ni is same as here. But please do not avoid to type 630 here. Sometimes solver have a problem to read this as input. Okay, when you write 630. Okay, so remember this. Sometimes I can see students still make us this mistake. So equals to available equals to click here. Okay. So make sure this is in formula. In this cell, when you want to run a solver, all area, this area, it should be in formula. Better in formula. This one is okay, no problem. Okay, because it automatically will generate the value here. But for objective and constraint, better in formula form. Okay, and same as sewing equals to 600, enter. Equals to here, click here. Okay, equals to here. Even though you can see display, the display is same as above. Okay, but because this is from the input here. Okay, so the input area, let's say you change your input. Okay, so instead of 135, the availability of inspection and packaging change to 140. So automatically this availability will change. Okay, so depends. So that's why better put a formula. Okay, sorry. Okay, so now you already set all the formula here. Doesn't matter, just you can let it, you can put any value or you can let blank. Okay, don't worry about that. Okay, so next only we go to data and click solver. Okay. All right, so objective, okay, already set objective to maximize the total profit here. By changing the variable, select here, okay? Select your decision. Changing the variable, select a decision, okay? Constraint, add a constraint here. Okay, constraint, you have 4 constraints. Okay, use here, constraint must be less than or equals to, make sure less than or equals to available, okay? Okay, you have 3 more constraints, so add, use here, use for sewing, less than, make sure you check less than or equals to available here. Okay, so add. Finishing here, okay, add finishing, less than or equals to constraint 708. Okay, don't type 708, just select the cell. Okay, add 100 inspection and packaging, use less than or equals to constraint available. Okay, so this is the last constraint, then just click OK. Okay, so now you have 4 constraints here. Okay, 19, 20, 21, 22. Okay, you can see 19, 20. Okay, so correct. Okay, you have 4 constraints. Okay, non-negativity constraint, make sure you tick this one. Non-negativity constraint. Okay, check here. And then make sure select a solving method. Sometimes by default they set as GLG or even evolutionary, but make sure you select simplex LP. This is a linear programming, okay? Simplex linear programming. And then after you set everything, then you have to click solve. Okay, solve it when you get this report ni answer sensitivity limits, means that you are in the correct way. Okay, sometimes it said unavailable. Okay, so report say unavailable or in any other message lah. Okay, as long as you get these 3, means that you are in a right way. Okay, you can see here now the figures already changed. Standard batch 450 and deluxe batch 455. Okay, so I need you to produce this report. Okay, these 3 reports. Okay, for the next punya explanation. Okay, for the future, just print the report and click OK. Okay, so now you have these 3 report here. and you get the solution here. Okay, so solver suggests you based on your constraint, okay, based on your resources that you have, okay, company par incorporation should produce 540 unit standard bag and 252 deluxe bag. So that the total profit, maximum profit is 7,668 based on the resources that they have. You can see a few resources, cutting and dyeing and finishing is already, you use all the maximum value, okay? But you still have an extra for sewing and inspection less than, but the value is less than available, okay? All right, so you already solved the problem. Now, I think you have to state your decision, okay? The decision. Standard bag. Standard bags to produce equals to 450 units. Deluxe bag (252 units) and maximum profit equals to 7,668. This is your maximum profit. Okay. All right. So you should mention your decision. Okay. Your decision from the Excel solver. Okay. All right. So from this report, first I will show you to answer your answer report here. Okay. So your answer report here, this is give you the answer lah. Okay. All right, so original value ni is based from the original value. Okay, so 10 standard bags and deluxe bag when you run the solver. If 0 and 0, it doesn't matter. 0. Okay, the original value is don't worry about original value. Okay, so the most important is final value. So final value is your decision. Okay, all right. So this is for constraint. Here, constraint. You can see constraint is status binding and not binding. Okay, so binding constraint, you have two binding constraint. Binding constraint means that you use all the resources that available. Okay, not non-binding constraint, okay, sewing and inspection is a non-binding constraint because they have an extra, still have a resources, additional 120 hours for sewing unused, and then 18 hours for inspection and packaging, unused hours. Okay, all right, so this is not binding. Binding constraint, you use all your constraint, use all that you are available that you have. Non-binding means that you still have additional or unused resources. Okay, all right. Yes.
Doctor, how to get this answer report and sensitivity report?
When you run the solver here, run the solver. Sorry. Okay, run the solver, and you solve. When you click solve, you can see yes, this area. Can you see my pop-up result? Solver result.
Yes, doctor.
Okay, good. Okay, so you can see on your right, on the right, you can see this is a report, isn't it? So click each report. Click here.
Okay.
You click and then click OK because I do it 2 times, so I get 2 reports here. Okay.
Okay, doctor. Thank you.
All right, welcome. Okay, so this one, okay. Let me delete first. Okay, this is just to give your decision and the status of each constraint. Okay, So whether there is an unused constraint or not, and your decision and your maximum objective. Okay. All right. Next time I will explain to you. We have a special section for sensitivity. Okay. All right. This is related to sensitivity too. Okay. Okay. Any question? Maximization. We already complete the maximization problem. Okay, this is explain everything what we do in the Excel. Okay. All right. Okay, if you have no more question about getting a maximization, I think we take a break for about 5 minutes or more like 10 minutes before I proceed to next simple minimization. Okay? Okay. Okay, we will continue with the next simple minimization problem. Okay, all right, same as the step, same as maximization, only that the difference is the objective. Okay, you have to set as a minimization. Okay. Good. So we will use M and D chemicals as an illustration for simple minimization problem. Okay. All right. So M and D chemicals produce two type of products, product A and product B. Okay. Right, two type of chemical products lah. Okay, chemical product A and product B. Okay, so this is the requirement for production requirement for M&D chemical. Okay, so the first requirement is both product A and B, the combination for both product must total at least, okay, so at least 350 gallons. 350. Okay, so total combined A and B at least 350 gallons. So you have to understand the problem carefully. Okay, and then separately, a major customers order 125 of products A must also be satisfied. Means that this company, M&D Chemical, already secured 255 gallons of product A. Okay, so means that you cannot produce product A less than 125. You have to produce more than that because you already secured the 135 gallons for product A from your customer. Okay, all right. So this is a requirement, both combination and the requirement for product A. Okay, so processing time. So another requirement is processing time, 2 hours per gallon to produce product A and 1 hour per gallon for product B. And total availability is 600 hours for processing time. Okay. Okay, production cost. Okay, so next information is production cost. Product A cost, okay, $2 and product B to $3 per gallon. So the objective here to minimize the total production cost. Okay, minimize. So same as previously. First, you have to understand thoroughly, and then you have to determine the objective and objective, constraint, and then assign the variables, and then write in terms of mathematical statement for objective, and write the mathematical statement in terms of mathematical statement for constraint. Okay, all right, so from here you can see objective to minimize the total production cost. Your decision is number of product A to produce and product B to produce, number of gallons. Okay. All right, this is sorry. Okay. Exercise. Okay, so product okay, so this is a first constraint, total combination product A and product B. Second constraint, and then last, the third constraint, processing time. Okay, right? Let's see. Oh, okay. Okay, so first I say okay, so first you have to understand the problem. M&D chemicals produce two type of products. Okay, the objective is to maximize to minimize the total production cost, minimize it by determine the number of product A to produce and number of gallons of product B to produce. Okay, 3 constraint, total production, the minimum requirement for product A, and also production hours. Okay. All right, so let's say you assign, okay, so your decision is product A and product B. Okay, so let me assign the variables for each decision. Okay, so let you assign A for product A and B for number of products, number of gallons of product B to produce. Okay, because now we still don't know what is a number of product A to produce, number of product B to produce. So A and B will represent for product A and product B. Okay. All right. So now we write in terms of mathematical statement. Where's the whiteboard? Sorry. Okay. All right. Okay. So based from this illustration, we will write the mathematical statement. Okay. All right. So mathematical statement here, to minimize. Okay. So to minimize the objective function here, you have $2 per gallon for product A and $3 gallon, $3 per gallon for product B. Okay. All right. So 2 for A plus 3 for B to minimize. So this is your objective function. Okay, to minimize the total cost is subject to constraint. You have a 3 constraint. Remember, 3 constraint here. 3 constraint. First, the total combination, and second is the minimum requirement for A, product A, and then processing time available. Okay. All right. So first is production time. Both production must be at least 350. Okay. A and B must be total at least 350. Okay, so how to represent this? A, number of A to produce plus number of B at least 350 means that more than or equals to 350. Okay, so this is a total production. Total production. Okay, A plus B at least 350 means that more than or equals to 350. A at least 125. So you should produce because you already secured the order from the customer, 325 here. So A, you must produce more than 125 minimum requirement for A. Okay, so next is processing time. Okay, so processing time here to produce product A 2 hours and product B 1 hour. So the availability is 600 hours. Okay. 2A plus 1B less than or equals to 600. Okay. So the sign is depends to the requirement. Okay. So in this case, the available only 600. So you can use more than 600. Okay. This is for processing. Okay, processing time. Okay, so now three constraint, and the last one A, B, non-negativity. Okay, this is non-negativity. Constraint. Okay, so this is a non-negativity constraint. Okay, all right. So this is objective function, and this is all the constraint. Okay. Okay. All constraint here. Okay, so that's how you transform the statement here into a mathematical statement. Okay, so now we want to determine what is the number of production for product A and product B, and what is the minimum total cost. So if you have a MND file, you can open MND files. Okay. Okay, this is how it should look like lah, your Excel. Okay, so that one is okay, because I already used the previous semester, I forgot to reset again. Okay, so this is the input area, processing time 2 hours for product A, 1 hour for product B, production cost for each product A and B, and then minimum total production and product A, minimum product A, and availability of processing times. Okay, so this is your decision area, your objective, and then your constraint here. Okay, so your constraint. Okay, so first, before we go to the solver, first we have to set the formula, relevant formula. Okay, all right. So minimize total cost. Go back to our minimize total cost. This is in form of linear form. So linear form 2 times A cost times the number of product A and product B to produce. Okay, all right. Cost number. This is number of product B. This area is A and this is B. Okay. All right. So this is cost. Okay. Okay. So now we set the formula to calculate minimum total. Okay. So because in a linear form, so use sum product. Okay. So sum product. Sum product. Cost. Okay. Cost times by product A and product B. Okay. Comma and product A and product B. Select and then enter. Okay, so still 0 because you don't have any value. Let's say you just put the, any value here, then you will get a cost. Doesn't matter. This, don't worry about you put any value. You don't have to follow me. You can put any value. Okay, product A, the minimum product A provided, minimum requirement for product A is equals to formula equals to product A lah. Okay, select product A. Enter. Okay, provided product A. So now you produce product A, then so whatever value here, is in this one, product provided. Okay. Delete first. Okay. I delete the formula pula. Equals to product A here. Okay, enter. Total production, because total production, okay, A plus B equals to okay. So total production A plus B more than 350. Okay. All right. So it's not a linear. So equals to sum A and B. Okay, just sum je because it's not linear, so it's a sum. Okay, enter. Okay. All right. So provided required here equals to, okay, make sure you put all here, you put a formula. Product A requirement, product A minimum. Copy here and enter. Okay. Do not avoid to write 125. Type manually. So avoid to type manually. Okay. Even though you can see the display to similar, same, but when you run a solver, sometimes solver cannot read the figures. Okay. It will read better with the formula. Okay, so total production is equals to 350. Enter. Okay, so this is a requirement for product A and total production. So ours use here, go back to our ni. So ours use is 2A plus 1B. So in linear form, so we should start with a sum products equals to sum product. Okay, so processing time and number of product A and product B to produce. Okay, so enter. Okay, still 0 because this is 0. So ours available is equals to our available here. Equals to available. So if you want to see unused hours here, you can select here unused hours equals to available minus set the formula available minus hours used. Okay, so enter here. Right, so now unused 600 unused hours. So if you set here, let's say 100 here and 100. Okay, so you get this. Still hours used, you have unused hours. Okay, all right, so requirement still not fulfill the requirement. Okay, okay, I just want to show you if you let it blank here. Okay, fingers blank here. Okay, so after you set everything, go to data and then click solver. Okay, so click solver. Okay, so I have to reset all. Okay, I have to make sure clear everything. Reset. Okay, so set the objective. Red color is your objective. Click red objective. This is to minimize, so make sure you change it to minimize. Okay, if you don't change it, then you won't get a good result. Okay, by changing the variables is your decision here. Okay, changing the variables. Subject to constraint, so add the constraint. Product A should produce more than required. Okay, so select more than. Add. Okay. Total production here, combination is more than 350 here. Click. Add. Okay. Hours use. Okay, so hours use here is should be less than or equals to hours available. So you have 3 constraints. Okay. Okay, now you have 3 constraints for production A, total production, and processing time. Make sure you tick this. Okay, non-negativity constraint. So this is the last one. Select a solving method is simplex linear programming. Okay, so after everything is okay, then click solve. Okay, so when you click solve here, you click answer, sensitivity, and limits reports. Okay, and then click OK. Okay, go back. Okay, now you can see this is your solution. Okay, so based on this, based on the solver, it provides to you. Company MND Chemical should produce product A 250 gallons, Product B 100 gallons, and then the minimum total cost would be $800. Requirement here, you fulfill all the requirement. Product A more than 125. Total production 350 equals to 350. It's because it's more than or equals to 350. Hours use 600, so you use all processing time. Okay, right? So you go to the answer report here. You see when you doesn't put any value in your decision area, so original value would be 0. Okay. So original value ni doesn't matter. It depends to what value you key in before you run the solver. Okay. So final value here 800, and then 100, 250 for product A and product B. Now in the constraint area, you can see product A is not binding. Product B, total production is binding and processing hours B. Okay, so for the cases is more than, okay, so processing hours ni means that you use all resources available. But product A not binding is they not use all resources. Okay, so in this case, they produce more than minimum requirement. Okay, not binding means that produce more than minimum requirement. It's not they have an extra. Okay, so it's surplus. This is called surplus. By Excel, it's standardized, so they just produce select. But it's actually if the constraint is more than or equals to, and you have it's not binding, means that you have a surplus. You produce more than the minimum requirement. Okay, so product A minimum requirement 125, you produce more than 125. Okay, you have a surplus 125. Total production minimum requirement 350, you produce 350 for total production. Okay, combination both 350, but product A itself 250. Processing time availability is 600, you use all 600. Okay, all right, so this is your decision. Then you should write your decision lah. The decision. Okay, product A 250 gallons. Product B 100 gallons produced, and total minimum cost equals to 800. $800. Okay, right? Okay, so that's all for linear optimization on the first part. Okay, we have a few parts after this. Okay, so for the first part, that's all for maximization and minimization problem. Everything is same. Okay, the step is still same. Only that you have to remember whether it's more than or less than your constraint. Okay, all right. So do you have any question? Okay, so no question. I assume okay, no student ask. I assume you have no more question. That's all for today. I will see you next week on Thursday. Okay. All right.